You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back, everyone. You know, it really is a fascinating time to be looking at the state of cyber defense, isn't it? Here on The Vocal Technologist. We've gone way past the point where security just meant, having a decent spam filter. What we're really seeing now is this kind of systematic breakdown of trust. Attackers are deliberately going after the systems, the tools, even the security things we kind of take for granted.
That really hits the nail on the head. It's the core issue. I mean, the intelligence we've been sifting through, it covers such a broad range. Everything from clever social engineering tricks aimed at employees, all the way to these super deep, complex firmware bugs, and frankly, some pretty major compliance gaps.
Right.
So yeah, our mission today, if you like, is to take all these technical details and, well, boil them down into something clear, something you can actually use. We want to focus on how and where the trust you rely on is being turned against you.
Okay, let's definitely unpack that. Starting with, I guess, the most common target. People, us. Most of us spot the really obvious phishing emails now, but the criminals, they've gotten so much smarter at using processes and brands we just inherently trust. Like, I was looking at these fake password manager alerts. They look scarily real.
Oh, yeah. And what's really quite clever in a devious way is targeting the very thing meant to protect you, right? Your password manager. We saw these big campaigns sending out fake breach notices pretending to be from LastPass or Bitwarden, the popular ones. The email tells you, panicked as you might be about your passwords, that you need to download a, quote, secure desktop version to fix things.
And that's the trap, obviously.
That's the trap, exactly. That download isn't secure at all. It's malware. But, and this is the tricky part, it often hides by installing legitimate IT management software. Things like the Synchro MSP agent. It's a common tool lots of IT departments use.
Oh.
And that agent then maybe pushes out something like ScreenConnect, which gives the attacker full remote access, persistent access. And it looks completely normal from a system perspective.
So the malware isn't some weird unknown file. It's actually being installed through tools that might already be approved or expected on the network. That makes spotting it way harder.
Yeah.
But what's the absolute key thing people need to remember here? The defense nugget.
It's actually pretty simple, but so critical. Legitimate password manager companies will never ask for your master password over email. Never. And they certainly won't push you to download some random program because of a breach. Any real security news will be on their official website, their official blog.
Right.
If you get an email like that out of the blue, assume it's bad news.
Right. Treat it as hostile immediately. Okay, speaking of traps with immediate financial consequences, let's talk about this Payroll Pirate scam. This sounds really sophisticated because it's aimed at organizations. Universities specifically seem to be a target, hitting HR systems like Workday. This isn't just trying to get a login, is it? It's actually getting around our main defenses.
Yeah, this one specifically gets around multi-factor authentication, MFA, which we all rely on, right? It uses something called an adversary-in-the-middle, or AiTM technique. Essentially, they trick the user into logging in through the attacker's proxy server. So the attacker grabs the username, password, and even the real-time MFA code or session token. Once they have that valid session, they move really quickly.
Wait, if MFA, which everyone pushes as, the gold standard, can be bypassed like this for high-value targets like HR systems, does that mean MFA isn't as strong as we thought?
Well, it definitely raises questions about how MFA is implemented. Password-based MFA is still way better than just a password. But yeah, attackers are really motivated to find ways around it, especially for valuable targets. And once they're inside that university system, they go straight for the goal, changing the direct deposit info.
Oh, okay.
And crucially, they try to hide. They set up inbox rules to delete any payroll notifications, maybe add their own phone number for account recovery later. It's a full takeover, steals money directly, and often, the victim doesn't know until payday comes and goes.
Oof, that delay makes it even worse. Okay, let's pivot slightly to maybe one of the most visible failures of, let's call it legacy security, SIM swap fraud. We saw a report about the UK. The increase was just astronomical. A 1,055% jump.
Yeah, that number is staggering, and it really shines a light on the systemic risk of relying on phone companies for securing financial stuff. Basically, attackers pretend to be you, they convince the mobile carrier to switch your number to a SIM card they control, and boom, they start intercepting all those SMS codes for two-factor authentication. Then they just drain bank accounts, crypto wallets, you name it.
So the warning signs: if your phone suddenly loses service for no reason, Or you get a weird text about a number transfer you didn't ask for. That's
Yeah.
basically panic time.
Yeah, absolutely. Red alert. And the defense here is really clear. There's no wiggle room.
Yeah.
You have to move away from SMS-based 2FA for anything important. Financial accounts, cloud services, anything sensitive. Use authenticator apps. Or even better, get a hardware key, like a YubiKey. That's really the baseline now. And call your carrier too. Set up strong PNs. Ask about port-out protection. Make it harder for them to steal your number.
Okay, so that's the failure of trusting external systems like telcos. Let's switch to the failure of trust inside our own machines, in the core hardware itself. And this is where it gets, well, really deep and kind of worrying. The framework BombShell, the UEFI firmware issue.
Yeah, this one hits right at the foundation of the computer security. Researchers discovered that on about, 200,000 framework laptops, the UEFI shells, that's the software that runs before Windows or Linux even starts, contained these dangerous commands. Specifically, commands. And these shells were signed by Microsoft.
Signed by Microsoft. So they're trusted. And what do commands do that's so bad in that pre-boot environment?
Stands for memory modify. They let you directly change stuff in the system's memory, which is incredibly powerful and definitely something you don't want easily accessible in production firmware. Attackers can use this trust the fact the component is signed and therefore allowed to run to actually overwrite crucial security pointers in memory, like the pointers for secure boot validation.
Whoa, so they're not hacking secure boot itself. They're just telling the system, hey, when you check for security, look over here instead, pointing to nothing useful.
That's a great way to put it. Yeah. It effectively just disables the signature verification for whatever the attacker wants to load next, like a malicious bootkit. And here's the really insidious part. Because the initial check passed, the operating system boots up and still reports that secure boot is enabled and active. Even though it's been completely undermined, its persistence at its most fundamental and totally hidden from standard checks.
That is genuinely terrifying.
Yeah.
The system is effectively lying about its own security posture. Wow. Okay. And speaking of persistence and hiding, we're also seeing attackers, including nation-states, abuse of all things, the blockchain to distribute malware.
Yes, this is a fascinating tactic focused purely on making the malware impossible to take down through normal means. Groups, including some linked to North Korea, are embedding malware, or parts of it, into smart contracts on public blockchains. Think Ethereum, BNB chain.
Wait, hang on. How do you hide malware in a smart contract? Aren't they just for, like, code that executes transactions?
They are, but you can stash data in various places, maybe in unused function parameters, metadata fields, sometimes even embedded within transaction data itself. And because the blockchain is immutable, you can't change it and distribute it, that malicious code becomes resistant to takedowns. You can't just call up a hosting provider and say, take this down. It creates this sort of bulletproof delivery channel, and it's really hard to trace back to the source.
That's kind of genius, in a scary way. Using the core feature of decentralization and immutability as a weapon to guarantee malware delivery. Have we seen anything quite like that before, that level of resistance to takedown?
Not really at the scale or this integrated into the infrastructure itself. It's a clear example of attackers adapting cutting-edge tech for their own resilience.
Okay, now let's talk about maybe a more direct kind of betrayal. Security's own tools being turned against us.
Yeah, this raises a really important question, doesn't it? What happens when the tools meant for defense are used for attack? We've seen threat groups like one called Storm 2603 weaponizing Velociraptor.
Velociraptor? Wait, that's a well-known open source tool for digital forensics and incident response, right?
Yeah.
DFIR stuff.
Exactly. It's built for sysadmins and responders to quickly grab forensic data from lots of machines. But attackers are using it because, well, it's powerful, it's often trusted or whitelisted, and it lets them conduct reconnaissance and move around the network really efficiently before launching ransomware like Lockbit or Warlock. They blend right in. Their activity can easily look like legitimate security scanning or investigation.
So they're basically using the security team's own flashlight to find the valuables before robbing the place.
That's a perfect analogy. And we see similar thinking with other evasion techniques too. Like there's this tool called EDR freeze. It's designed to temporarily disable endpoint detection and response software, your EDR, but it does it without needing a complex kernel driver, which is often harder to deploy. Instead, it abuses a legitimate part of the Windows error reporting system, WEAI, to basically just pause the EDR's processes while the attacker does their dirty work. It's this constant cat and mouse game, always trying to misuse trusted system components.
Right. Which leads us neatly into the really big picture issue. Supply chain risk. Attacks on major vendors can instantly put thousands of downstream customers, maybe you listening right now, at risk.
Absolutely. The F5 networks breach is a prime example. We learned that state-backed hackers had, quote, long-term access. They stole source code, yes, but also, critically, customer configuration data. The potential fallout is massive. We're talking possibly over 1,000 companies, including big Fortune 500 names whose specific, detailed network configurations might now be in the hands of adversaries.
Wow. That means your security is only as good as your vendor's security, essentially. Their source control, their internal practices. But let's flip that. Let's look at a positive case where good architecture and quick response actually worked. The reaction to that big Redis vulnerability, the one rated CVSS 10.0.
Yeah, Report URI gave us a great little case study there. When that zero-day vulnerability hit, their first move, the immediate fix, was crucial. They used access control lists, ACLs, to block the specific risky Redis commands, evil and evilosha. These are often the way attackers get remote code execution in Redis.
Okay, so that's the emergency brake. What allowed them to actually fix it properly without disruption?
It was their existing setup. They were already using Redis Sentinel for high availability. That meant they could upgrade the Redis nodes one by one with zero downtime for their service, rolling upgrades. But here's the real lesson. Even before they applied the ACL block or the patch, their existing defenses, things like keeping the Redis cluster isolated on the network, having strict firewall rules, likely meant they were already protected from external attacks anyway. It shows that layers matter. Rapid response plus good existing architecture is the winning combo.
That's a great point. While we often focus on server stuff, we absolutely cannot forget the huge blind spot, especially for anyone in e-commerce: client-side security. That third-party JavaScript running in your customer's browser, this is super relevant with holiday shopping seasons always looming.
Oh, the risk there is enormous. The stats are pretty worrying. Something like 73% of e-commerce sites load 50 or more third-party scripts just on their checkout pages. Think analytics, ads, chat widgets, payment processors, but only about 23% are actually monitoring those scripts for malicious behavior. And attacks like a polyfill.io supply chain attack exploit this massively. The malicious code runs in the user's browser, scrapes the payment details right there before it even gets sent to the server. So traditional defenses like a web application firewall, WALF, are completely blind to it.
Which explains why these skimming attacks can go undetected for ages. The average was, what, 7.5 months? If the wave can't see it, how do you defend that checkout page?
You have to lock down the browser environment itself. The main tool is a strong content security policy, CSP. It's basically a set of rules you send to the browser telling it what kinds of content, like scripts, are allowed to load and from where. But, critically, you need to use nonces. These are unique, random tokens to specifically approve individual legitimate scripts.
So it's like giving the browser a very specific allow list for scripts, verified with a secret handshake each time.
Exactly. You absolutely must avoid using unsafe inline in your CSP, as that basically turns it off for inline scripts. And on top of that, you should use sub-resource integrity, SRI, tags for any scripts you load from third parties. SRI uses a hash check to ensure the script file hasn't been modified between the server and the browser. It verifies the integrity of that external code.
Okay, makes sense. Secure the browser. Now, finally, we have to touch on the newest frontier, AI security. Integrating AI, especially large language models, brings a whole new set of trust and security challenges right into the enterprise.
Absolutely. It's a huge area. When companies hook up large language models, LLMs, to their internal systems, they often use this middle layer, sometimes called a Model Context Protocol, or MCP. This lets the AI access internal databases, trigger actions, things like that. But this MCP layer creates a brand new attack surface that, frankly, most traditional security tools just weren't built to monitor or understand.
So the AI effectively becomes another user on your network, potentially a very privileged one, accessing sensitive data. What are the main ways this can go wrong?
Well, we're seeing a few key risks emerge. First is prompt injection. That's where an hacker crafts malicious input to trick the AI into ignoring its safety rules or instructions, maybe getting it to leak confidential data it shouldn't. Second, there's the supply chain risk within the AI model itself. If you're using a pre-trained model, could it contain hidden biases or even malicious logic? And third, there's the risk of rogue or shadow MCP servers being set up without proper security oversight, potentially siphoning off data completely undetected.
The challenge seems to be monitoring not just if the AI can access something, but why it's asking and what it intends to do. It's like monitoring the AI's intent, almost.
Exactly. It requires new kinds of specialized tools. We're starting to see platforms emerge, like MCP Total was mentioned, that focus specifically on this AI interface layer. You need really granular visibility into those AI to system connections, strong authentication, and policies that check if the AI's request actually makes sense in its current context. Without securing that context layer, you're essentially giving a potentially unpredictable agent the keys to the kingdom.
Okay. So if we try and pull all these threads together from today, the theme seems clear. The biggest dangers right now are hiding in places we tend to implicitly trust. It's the firmware that's signed but lying. It's the legitimate IT tool being misused. It's the HR portal where MFA wasn't quite enough. It's the third-party script on your website. And now it's the AI interface talking to your core systems.
That's the core insight, definitely. And the answer isn't just throwing more tools at the problem. It's about building more resilient, layered defenses. Defenses that are adaptable and allow for really rapid response when things inevitably go wrong, like we saw with that Redis example. Security can't be a static thing anymore. It has to be dynamic.
And, that actually sets up a really interesting final thought for everyone listening. We've seen proposals bubbling up for a new compliance framework. It's called Alico-V assurance levels for control, operating viability, and effectiveness. And the idea is basically to replace SOC2. Because let's be honest, SOC2, while necessary now, is fundamentally flawed, right? It's a snapshot. It proves you were secure at one particular moment in time, maybe months ago.
Right. Alico-V aims for something different. Continuous monitoring. Threat-informed requirements. It wants to shift compliance from being this backward-looking audit report to a real-time dashboard showing your actual security health now. And the really interesting angle is how it could potentially link up with things like cyber insurance.
Imagine that, right? Your cyber insurance premium could be directly tied to real-time data, proving your security controls are actually working, continuously. Discounts for demonstrating ongoing effectiveness, not just for passing an audit 6 months back. So the question to leave you with is this. If compliance itself is moving from that static snapshot to a live, continuous feed, how ready are you? How ready is your organization for that level of constant transparency? Still about trust, but maybe it's trust that needs real-time verification. Something to think about. Until next time.
Spoken Tech for your ears.